Welcome everyone. Today we are diving into the fascinating world of digital circuits by exploring the full adder circuit. In our previous discussions, we covered half adders, and now we will take it a step further with a full adder, a crucial component in arithmetic logic units and processors. Uh, what are the explanation of half adders? Before we jump into the full adders, let's do a quick recap of the half adder. As we know, a half adder can add two single bit numbers, producing the sum and carry outputs. However, it has limitations when dealing with more complex additions involving carries from previous bits. Now we will move towards the full adder. This is where the full adder comes in. It can handle three inputs, two bits to be added, and a carry input from the previous stage. It produces a sum and a carry output, making it essential for multi-bit addition. Let's break down the logic of a full adder. It comprises two half adders. If you can see the screens, here we have a one half adder, and this one is the second half adder, and an additional OR gate. The first half adder calculates the sum of two bits, and while the second half adder computes the sum of the outputs from the first adder, as you can see here, and the final OR gate combines these results here. Okay, and this generates the total sum here. Now let's illustrate this concept with a practical example. We'll walk through the step-by-step addition of two multiple bits number using full adders, showcasing how the carry propagates through the different stages. And let me show you here. If you can see here, if all the three inputs are 1, it means the sum of 2 are 1 is here we get 2 bits, and the 1 is the carry. That's fine. I hope you all of you understand that what is the working principle of the full adder and how it's working in case of uh, all the three conditions when we have the three numbers. I mean to say two numbers to add, two bits to add, and one as a carry. If you can see here, if there will be no carry, you can see the sum we have is high or 1, and there we have no carry. And if we talk about the applications and significance of the full adder is not just theoretical, it's the building block for arithmetic units in CPUs, enabling complex mathematical operations that power computers and various digital devices. And there you have it, the full adder circuit, a critical component in digital circuits and in computing. I hope this video has provided you with a clear understanding of how this fundamental circuit works. If you enjoyed this video, do not forget to like, share, and subscribe for more content on digital electronics and circuitry and projects. Thank you for watching the video, and if you need any type of assistance in assignments, exams, and projects relevant to the electrical and electronics, please ping me a message to my WhatsApp number, and you can also visit my Upwork and Fiverr profile. Thank you so much for watching the video.